Hi everyone. Today we are going to look after the continuous beams ILD, calculating ILD for a shear force point. So this is the given problem. So in this problem you can see that there is a point D where they have asked to find out the shear force at this particular point, which is 3 meter from C. So let us now look after the session. As per the Muller-Weierstrass principle, we need to remove whatever there may be and we need to apply the unit of anything, rotation or even displacements. So in case of shear force, I am applying the unit shear force. See, I have cutted the section, D has been splitted and I have applied the unit shear force. So the value is 1. We know that the value is 1. It's a unit shear force. The rotation differs, but the angle of rotation will be same. In the previous model problem, the deflection is same. So that is the point we need to consider here. For this particular condition, while they have asked for the determination of shear force, the slope will be similar but not the deflection will be similar. So this is the one rotation. See, I have been splitted into a region of DC and DA, and I have also plotted the region DC and DA. See, this is the thing. So I am going for the calculations of reactions. So it's very simple, that just taking summation V equal to 0, here it is 1 and here it is 1. So the reaction at C is 1. So the moment at D will be 1 into 3, 3. And I'm calculating the reaction for this span, which is DA, D to A. So this is D and A, B and D. So I'm taking the moment at A equal to 0. I'm calculating that moment. So you need to always keep in mind that while calculating the moment, you need to apply the moment value as 3. Since we have calculated here, so the moment will be same. So in case of shear force, the moment will be same. In case of determining the theta or slope, the deflection will be same. That is the thing we need to keep in mind. So in case of here, the deflection, the moment will be same. I am taking the moment of 3 valued here, since the moment is same, and calculating it into the reaction and finding out determining the reactions RB and RA. So that's it. We are calculating a moment at X is equal to, taking the section X, see from here. So I am calculating the moment 1 into X, and for here 2 into X minus X, and integrating it, applying the Macaulay method. So I am integrated and find out the slope equation, and also I have calculated the deflection equation, and substituting the boundary condition at X is equal to 0, Y is equal to 0 and X is equal to 9, we have the slope we can determine, and at X is equal to 6, since these are the supports, the support is 0 and 6 meter. So at X is equal to 0, Y is equal to 0, at X is equal to 6 meter, Y is equal to 0. Applying the condition, I have determined the C2 and C1 values and I have substituted in the corresponding equations. After that, I need to find out what is the value of here. So I need to find out the deflection value. Since we know that the shear force is may be calculated as Y of XA divided by Y of DA minus Y of DC. So Y of DA and Y of DC is to need to be calculated. So I am calculating it. So at X is equal to 9 meter, so theta D I have calculated both the slope and the deflection value. So let it be. Again I am coming to the small section. Always in case of calculating the shear force or even the moment as the section, you just complete the complicated segment and come to the simplest structures. That is for the calculation purpose. That is the simplest way of calculation. You should not go from the simplest structure to the complicated structure. You just solve the complicated structure, then the simple structure will be very easy. So I have written the moment at section is 3 minus X, and I have integrated it and found out the deflection slope equation, and again integrated it and I found out the deflection equations. And applying the limit at X is equal to 0, see this is the point X, but here X is equal to 0, we have the slope value, right? Theta D, we have found out the theta value as 25.5. On substituting it, I am getting it as C1 in the value, and at X equal to 3, the Y is equal to 0. See, this is X and X equal to 3, this is a point, it is a support. So support does not deflect, therefore the slope will be equal to 0. So at X is equal to 0, Y is equal to 0, X is equal to 3, Y is equal to 0. We have determined C2 as 85.5, and correspondingly I have substituted in the equations slope equation and deflection equation. For these substitutions you may even refer my previous videos, which will be helpful for you. And I am finding out the deflection at this point. So Y at DC is equal to Y 85.5 and divided by EI. So we have got YDA and YDC. So YDA minus YDC gives you the denominator factor for shear force. So I am substituting it, and I have determined that Y of XA, the shear force is Y of XA divided by 144 divided by EI. And correspondingly, you know from which limit to which limit you should substitute the equation. I have mentioned in all my videos. So correspondingly, I have mentioned the equations. I found out the ILO. Since there is a point, you need to see the shear force point is 9 meter. and for the right case it is taken as 0. For the previous video I will taken the videos as sum. From here onwards I am substituting the x value as such x value itself. So since shear force, there will be a left side equation and there will be a right side equation. So for left side equation you should substitute the value as 9 equal to 0, and for right side equation you should substitute the value of x is equal to 0. So and we have determined the two different values. See, for 9 meters I have found the two values. Since it is a shear force, so shear force I have the positive in value and a negative value. So all the values has been determined. I have plotted the profile. So this is how we are calculating the ILD for shear force at particular point in a continuous beam. Thank you.